so I want to look at now circle theorems. Really tricky, really hard. Absolutely no chance of being on foundation. It's a higher topic, grade A start. So the plan is I'm going to talk you through the 8 sort of main rules or theorems, and just give you 2 examples, and then obviously if there's any more help that's needed you can write comments and I can put some more videos on. So the first rule is we've got a tangent, we've got a radii or radius, but the radius meets a tangent always at 90 degrees. So what you've got to understand is the questions are never going to be this basic, ever. What's going to happen is these are just the rules and then they combine them all and make a crazy picture, and you've got to pick out the rules. So they're always going to be 90 that side, 90 that side. That's just always the case, but it's got to be coming from the centre to the outside. That makes the radius, and the tangent's going to be going at 90 degrees to that. 2 tangents meet outside the circle. So if we've got 2 radii coming out here with 2 tangents, when they meet, it means they're going to be the same length always. And as you can see by the diagram, you've got your 90 degrees there because the tangents are meeting radii. So that's from the last rule, and they're always going to be the same length. This is the isosceles triangle rule. It comes up quite a lot in the exams. They do tend to put this one in, and it means that we've got 2 radii, and then we join them up with a line. Well, their radii are always going to be the same length. So that's going to be the same length, that's going to be the same length. So that means you've got an isosceles triangle, which means that this and this are going to be the same angle size. So what sometimes they do is they'll give you that, and you've got to work that out by taking it from 180 and then divide it by 2 to get each individual angle there. But it's one they do tend to put in. Perpendicular from a chord, so we've got the chord, so that's just a line that's not going through the centre of the circle, that's the chord, straight there, and then we've got a line going from the centre to that chord. It's just going to make a 90-degree angle. Cyclic quadrilateral theorem, it's just 2 complicated words really for saying a 4-sided shape in a circle. So any 4-sided shape that can be drawn in a circle, the opposite angles will add up to 180. So for example, if I said that was 100 degrees, then that angle would be 80 degrees. If I said that angle was 120 degrees, that angle would be 60 degrees. And then because it's a 4-sided shape, all the angles will add up to 360 anyway. So opposite angles 180 in a cyclic quadrilateral. This one, angles in a semicircle, 90 degrees. So this is the one where the line that cuts through the, so call out the origin there, the centre. So a line that cuts through and then meets a circle somewhere. It could be there. It doesn't matter where that point could be. Anywhere here, it's always going to make 90 degrees. So it could be anywhere you go. So 90 degrees, and that's another one they tend to just throw in, just so you need it for something. The alternate angle segment theorem. The best way to show this one. Best way to show this one, this angle here, I'll use 2 different colours, that angle will be the same as this angle, and this angle will be the same as this angle. There's not really an easy way to remember that. It's probably the hardest theorem, well, from what I remember at school anyway. And I seem to remember thinking something like, the red line touches this line, So there's my base. That was my base, and then I thought, right, the two lines that come off that is the same angle. So this one here, quite complicated, I know, but that's just how I remembered it in my head. You can just remember that it's alternate, but the picture's not always that nice. So it's nice to have something that you can remember. But it's quite a tough one. So just to throw some numbers in, if that's 54, that's 54.